Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This video I'm going to start the next chapter, which is exponents. So this is the first video, part 1 on the chapter of exponents, where I will discuss about the integral exponents of rational numbers. How do you express about the exponential form of rational numbers where the power or index is an integer, and the laws of exponents. In this video, I will not solve any exercise problems. I will just discuss the concepts with some illustrative examples, and in the next video, I will solve the problems of exercise 2A. So this video is part of the playlist CBSE Maths for Class 8 following the textbook of author R.S. Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have my rough notes prepared on the left hand side on the topics that I will discuss in this video about exponents. So exponents you have already studied in your previous class 7. You have studied about exponents where the exponents of integers with powers as positive integers, and also exponents of rational numbers. And also you have learned the laws of exponents. So let's start discuss a little bit about the very fundamentals of the exponential form. So what is an exponent? So we know that we write exponents in the form that we write 2 to the power 4, or we write 3 by 2 to the power 3. Now what are all these? Now, so the basic definition of the exponential form is that when you multiply a number, that number could be the number is essentially has to be non-zero. We have, let's say, x is any number, not equals to 0, and so x could be integer, x could be a fraction, x could be rational number. Mainly we will deal with rational numbers. So a rational number can also be integers. So let's talk about rational numbers, where x is a rational number, but it is not equals to 0. It's a non-zero rational number. Now when we multiply x, this rational number x, let's say n times, where definitely n is a positive integer. N is a positive integer, that is, it could be 1, 2, 3, 4, 5, 6. We use the exponential form as a shorthand of this value, or number. We are multiplying x, a rational number, a non-zero rational number, n times. So as a shorthand we use the notation x to the power n. So over here, this is the exponential form. This is the exponential form where n is known as the exponent. So this is the very basics of exponential form. Exponent where n is known as the exponent or index or power, and x is the base. So in a number expressed in exponential form, we have two parts: the base, which is x in this case, and the power. The power is also known as exponent or index, and we have a base. So we call it base raised to the power n. So this exponential form, we call it in words we say x raised to the power n. So this is the very fundamentals of exponential form. Now, okay, now a little so when a few things to note is that when the rational number x, if it is a negative rational number, so I might be using some different letters and notations while I am discussing, and in the notes it could be different. So please don't get confused. Try to understand the concept. You can take screenshot of the notes while I am discussing the concepts. I will progressively scroll down the notes so that you can take screenshot for your future reference. So if what if so let's say x is a number. X is a number. Primarily we are discussing about rational number. Let's say x is a positive rational number. X is a positive rational number. Now what will be minus x to the power m? Minus x to the power m. Now this will be equal to x to the power m if the integer m is an integer. M is an integer. If m is even. If n is even. Now it could be a negative even integer or it could be a positive even integer. So if m is 2, 4, 5, 6, 7, 8 or m is minus 2, minus 4 like this, then it will be minus x raised to the power m will be equal to x to the power m. You can get rid of the negative sign of the rational number if m is even, but if m is odd, this will become negative of x to the power m, or better this. If m is odd, like 1, 3, 5, 7, 9 or even minus 1, minus 3, minus 5. Okay, you should keep this thing in mind. Okay, now let's talk about or discuss about the integral exponents of rational numbers. We will only talk about the exponential form of rational numbers where the exponent or the index of the powers will be integers. Now that integer could be negative integer, it could be positive integer, or even it could be 0. The power. So we will be talking about exponential form of rational numbers. That is, if a and b, we will talk about this. So now when we talk about integral exponents of rational numbers, please note that the rational number has to be non-zero. We are talking about integral exponents of non-zero rational numbers. Always remember that a by b is not equals to 0. Whenever we are talking about some powers of rational number, that rational number has to be a non-zero rational number. Okay. So what are the basics of the exponential form of rational numbers, or rational numbers having an integral power or index or exponent? So the concept for rational numbers is obviously the same. When we multiply a rational number, let's say a by b, which is a non-zero rational number. Let's say a by b, if I am multiplying a by b, the rational number, let's say m times, I am multiplying this m times, we write this expression or this product of the repeated product of this rational number a by b m times in the short notation as the rational number raised to the power m. So here a by b, the rational number, is the base, and the power and the number of times m is the power, index or exponent. This is the fundamental concepts of the notation of an exponential form of a rational number raised where the power, index or exponent is an integer. Okay. Now the next thing is when the power, that is integer, if it is a negative integer. So let's say if you have so while I'm not really following thoroughly line by line of my notes, I'm doing the discussion. So while I am discussing, you can take screenshot of the notes. So when the integer, the power m, is a negative integer, let's say it is if you have an expression like this, an exponential form like this, where m here m is a positive integer and a by b is a rational number, non-zero rational number. So the power is negative, minus m will be negative. If m is a positive integer, then minus m will be a negative integer. So this is nothing but you can you take the reciprocal of the rational number. The reciprocal of the rational number a by b is b by a, that raised to the power m. So this thing you should remember, that if a rational number is raised to a power which is a negative integer, then the result it is equivalent to or equal to the reciprocal of the rational number raised to the power where the power will be the same power but ignoring the sign. Now, so what exactly is this? A by the rational number a by b raised to the power minus m, where m is a positive integer, that is a rational number raised to the power raised to a negative integer as power. This is the reciprocal of a by b raised to the power m. The rational number raised to the power minus m, where m is a positive integer, is actually the reciprocal of the rational number a by b raised to the power m. Now we know that a reciprocal of a number, any number x, is 1 by x. So this is actually 1 by a by b raised to the power m. Now, okay. One more thing. Over here, when we are multiplying, so we know the basics of the exponential form of a rational number. That is, if you are multiplying the rational number a by b m times, we write it as a by b, the rational number raised to the power m. Now this is equal to the numerator of the rational number raised to the power m divided by the denominator of the rational number raised to the power m. So rational number a by b raised to the power m is in exponential form, but when you write it as a to the power m divided by b to the power m, then this is in a rational form. So this is a way to convert between an exponential form to a rational form, or from a rational form to an exponential form, using this formula. So this formula will help to convert a given exponential form of rational numbers to a rational number, or from a rational number to a exponential form. Now, so we were discussing the reciprocal of a by b raised to the power m. The rational number a by b raised to the power m, its reciprocal is nothing but 1 by a by b raised to the power m. Now, if I a by b raised to the power m, I know it will be a to the power m b to the power m. Now, so what is this? So this is 1 divided by a to the power m and b to the power m. 1 by this is nothing but 1 divided by a to the power m by divided by b to the power m. And we know that from the concept of division of two rational numbers, we know that if x and y are two rational numbers, then x divided by y is nothing but x multiplied by the reciprocal of multiplicative inverse or reciprocal of y. So this is nothing but 1 multiplied by a to the power m by b to the power m, its reciprocal. It's reciprocal. So what is this now? What is the reciprocal of a to the power m divided by b to the power m? It is nothing but we interchange the numerator and the denominator. The reciprocal of any rational number t by q is equal to q by p. So this will have b to the power m divided by a to the power m. This is equal to b. This is equal to b to the power m by a to the power m, and we know that this is nothing but b by a to the power m. So a rational number a by b raised to the power minus m is equal to the reciprocal of the rational number, that is b by a raised to the power m. Okay. Now, so so a by b raised to the power minus m and a by b raised to the power m, they are reciprocal of each other or multiplicative inverse of each other, reciprocal of each other. And you know that the product of the of a number and its multiplicative inverse is always equal to 1. So we will have, since a by b raised to the power minus m is the reciprocal of a by b raised to the power m and vice versa, we will have always a by b raised to the power minus m multiplied by a by b raised to the power m is equal to 1. So this is the very fundamental concept of the fact that any number and its multiplicative inverse is always equal to 1. Now, what if in this exponential form of a rational number, what if m is 0? If m is 0, it is by definition that a by b, any rational number a by b, if it is raised to the power 0, this is equals to 1. But always remember that the rational number in exponential form, the rational number base is always a non-zero rational number. So any non-zero rational number a by b, if you raise it to the power 0, it will always be equal to 1. Okay, so these are more or less the basics of the integral exponents of rational numbers. Now let's discuss the laws of exponents. There are some laws of exponents. So we will discuss about the laws of exponents of rational numbers. So if x and y are non-zero rational numbers, and let m and n are integers, m and n are some integers, it could be 0, negative or positive, and x and y are non-zero rational numbers. It is not 0, but it can be positive or negative. Then the law says that the first law is that x to the power m multiplied by x to the power n, that is, it is a product of two exponents. The first exponent is x to the power n, x to the power m, and the second exponent is x to the power n. The base are same. The product of two exponents where the base is same and the powers, the exponents are different, is equal to, the base remains same, we just add up the powers or exponents or indexes or indices. So this is the first laws of exponents. That is, the powers gets added when we multiply two exponents with the same base. The next is that what happens, this was the product of two exponents, two numbers in exponential form with the same base. Now what about if you divide two numbers in the exponential form having the same base but different powers? So this will be equal to, we just the base remains the same, we take the difference of the powers, so it will be m minus n. Since we are dividing x to the power m by x to the power n, so in the power it is x m minus n. Now okay, now this x to the power m minus n, if this again will be equal to this will be equal to now okay, so this is m minus n. Now depending on m and n, depending on the values of the integers m and n, m minus n could be positive or it could be negative. If it's a negative, it could be positive or negative. Okay. The next important formula is that we have a rational number in the exponential form, that is x to the power m. If you raise a number in the exponential form to another power, that is, if I raise x to the power m to n, the powers get multiplied, that is, it becomes mn. The powers get multiplied. So also, if you have like this, x to the power m, we have x to the power m, which is raised to the power n, and again it is raised to the power p. This will be nothing but x to the power m n p, m n p, m n p. So you just multiply all the powers. Okay. Now the next law is that the first one was the product of two exponents, product of two numbers in the exponential form, where the base of each exponent was same and the powers was different. What if it is the opposite case? That is, the bases are different. What will be x to the power m multiplied by y to the power m? That is, it is a product of two numbers where each number is in exponential form, that is x to the power m and y to the power m, and in both the exponential form the bases are different, x and y are different, but the powers are same. This is equal to, you just this will be equal to the product of the bases raised to the power common, raised to the power the common exponent or power, this. Okay. Now so I now I do not think you will require some examples to illustrate these examples. These are pretty straightforward things that you must know. So let me discuss all the laws, then I will try to solve some example problems. So this is this. Again, let's say, so remember, in this x and y are rational numbers. X and y are not integers, they are rational numbers, but non-zero rational numbers, and m and n are integers. If you have something like this, a rational number raised to the power m divided by another rational number raised to the power, same power, m, then you can write it as x by m, the division of the two rational numbers raised to the common power. You have this. So x to the power m divided by y to the power m is equal to x by y raised to the power m. Okay. What else do we have? And of course, if you have something like x by y, you have a division of two rational numbers x by y, and this is the raised to power some negative integer, integral power, that is, let's say m is a positive integer, so minus m will be a negative integer. So if you have x by y whole raised to the power minus m, this will be equal to y by x divided by y by x raised to the power m. Now also, in terms of integral power or exponents, remember that any rational non-zero rational number, if you raise it to the power 0, it is always 1. So any rational number, non-zero rational number, if you raise it to power 0, the result is always 1. And of course 1, which is a rational number, 1 raised to the power any integer is always equal to 1. 1 raised to the power m, where m is any integer, it is always equal to 1. So these are the basic fundamental laws of exponents of rational numbers. So So the important ones are this, all are important. All the exponents, all the laws of exponents are important. You need to be very familiar with all these laws, and that any non-zero rational number raised to the power 0 is always equal to 1. Now there are certain few things I have added extra which is not given in the textbook of author R.S. Aggarwal. So this is about comparing exponents of rational numbers. How do we compare? How do you compare two given numbers in the exponential form, that is exponents of rational numbers? So let's say if you have x and y are non-zero rational numbers and m and n are any integers, then so the first one says that xm x raised to the power m, where x and y are non-zero rational numbers. If you have something like x raised to the power m is equal to y raised to the power m, this will imply that x mod x is equal to mod y. Now what is mod? Mod is the absolute operator. This is the mod operator means you ignore the sign. Mod of x is whatever the value of x is. If it is positive, then it will be positive, and if it is negative, you just ignore the sign. So basically mod of -2 is 2, mod of 0 is 0, mod of 3 is 3, mod of -1 by 2 is equal to half. This is the concept of mod. So if you have something like this, if you have this equation, x raised to the power m equals to y raised to the power m, that is the power or exponent or index is same, then you can say that the modulo of both the bases will be same, or absolute value of both the bases will be same. Now why do we need to have the modulo? Why can't we say x equals to y? Because if m is, you know that if m is even, consider this thing, -2 raised to the power 2 we know is equal to 2 raised to the power 2. Why? This thing is nothing but -2 raised to the power 2. Earlier I have discussed at the very beginning that any number x, any non-zero number x, if x is a positive non-zero number, if x is a positive number, then -x is a negative number. So -x raised to the power m, where m is an integer, will be equal to x to the power m if m is even. And it will be negative of x to the power m if m is odd. So over here -2 raised to the power 2, the power 2, m is 2 here, it is even. So this will be equal to 2 square. But you can see the base, these two, -2 and 2, they are not equal. So I cannot say, if the power is a even integer, then you cannot directly say that x equals to y. You have to say that the absolute value of x is equal to absolute value of y. And if m is odd integer and m is odd integer, then definitely we can say that x will be equal to y. Just because in the case where m is an even integer, we have to consider that it will be mod x equals to mod y. Okay, so this was the first comparison of rational numbers regarding equality, where the power is same. Two numbers in the exponential form are equal, having same power, then the base will be equal. Base will not be equal, the absolute value of the base will be equal. Now in the part 2 it says that x to the power m, if we have, also in this implication it is double implication, meaning it is actually double implication, meaning if you have 2x and y, where mod of x is equal to mod of y, then it will imply that x to the power m is equal to y to the power m. Uh, mm, One second. If mod x is equal to mod y, but if mod x is equal to mod y, then but what if m is odd? If m is odd, if m minus 2, if m is odd, this will not be equal to 2 to the power 3. No, it will not be double implication. I do not think it will be double implication. But if x to the power m is equal to y to the power m, then we can always say that absolute value of x will be equal to absolute value of y. Actually, this will not be double implication, because double implication means that if mod x is equal to mod y, so we can consider x as minus 2 and y as 2, then definitely, and if m is odd, then it will not work, because minus 2 raised to the power 3 is not equal to 2 to the power 3, because the left hand side minus 2 raised to the power 3 is minus 8 and 2 to the power 3 is 8. So it is single implication. In the notes, please in the notes it is incorrect. It will not be double implication, but only single implication. That is, if x to the power m is equal to y to the power m, then we can say that the absolute value of x will be equal to the absolute value of y. Now the second one, it says that if we have x to the power m is equal to x to the power n, that is the base is equal, this will imply we have two equality of two numbers where each number is in the exponential form, and both the exponential form number we have the same base but the powers are different. So we can say that if the two exponential numbers are equal, the powers has to be equal. The powers has to be equal. Okay. Now, will this be double implication? Can we use double implication? If m equals to n, if for two integers m and n, if they are equal, then yes, this can be this is double implication. So if m equals to n for any two integers m and n, if they are equal, then we should have x to the power m is equal to x to the power n. This was regarding equality. Regarding inequality, we have if x to the power m is greater than y to the power m, where the power on both sides of both the numbers in the exponential form, the powers are same, that is m, but the bases are different, x and y. So this will imply x is greater than y only when m is a positive integer. The power m is a positive integer. This is coming from the fact that so you can see that if m is a positive, if only for m greater than 0, that for positive integer we will have x to the power m greater than y to the power m only if x is greater than y. X is greater than y. But we will have x to the power m less than y to the power m. This will imply, if x to the power m is less than y to the power m, this will imply x less than y. Also, if m is greater than 0. So for m greater than 0, if m is the power is a positive integer, we have two cases. If power m is a positive integer, then if x is greater than y, then we will have x to the power m greater than y to the power m, and if x is less than y, we will have x to the power m less than y to the power m. Now, why so? Let's say you can see that let's try to understand this result. So let's say m is 2. It could be 1, 2. So m is a positive integer. Now let's consider. So if you have let's consider x equals to 3 and y equals to 2. So now x to the power m is equal to 3 square and y to the power m is equal to 2 square. So we can see that 3 square is greater than 2 square. Okay. Now why it is that if x is less than y, then x to the power m will be less than y to the power m. For m greater than 0, we are talking about m is a positive integer. Okay. So definitely if so now you can see if x is equal to, let's say, 2 and y equals to 3, definitely we will have 2 square less than 3 square. 2 square is less than 3 square. So if the base is small, if the bases, if you raise two bases to the same power, same positive integer, and one base is small and one base is greater, then the smaller base raised to the power will be obviously be smaller than the greater base raised to the same power. Okay. So this was 2 and this was 3. This was 4. This was 4. Now, what if the inequality will change? The inequality will change if the power m becomes it's a negative integer. So now we will have xm xm less than y to the power m will imply x greater than y, and double implication. Over here also we will have double implication. If m is less than 0, if m is a negative integer, then we will have if we have x to the power m less than y to the power m, this will imply that x is greater than y. Why is it so? Because let's say let m is equal to minus n. M is equal to minus n, where n is some positive integer. Since m is a negative integer, we can always write m as minus n, where n is a positive integer. So x to the power m is equal to x to the power minus n, and we know that x to the power minus n is nothing but the reciprocal of x to the power n, that is, this is 1 by x to the power n, and similarly y to the power m will be equal to y to the power n is equal to 1 by y to the power n. Now you see if x is larger than y, then if x is larger than y, x greater than y will imply definitely x to the power n greater than y to the power n, because n is a positive integer. We have expressed m equals to minus n. We are considering that m is a negative integer. Point number 5, we are considering m is a negative integer. So we are saying that let m equals to minus n, where n is a positive integer. So if n is a positive integer, then x to the power n will be greater than y to the power n, where x is greater than y. So this implies 1 by x to the power n will be less than 1 by y to the power n. Now you must know that if for any two, this is a concept of inequality. If a and b are two non-zero numbers, if a and b are two non-zero numbers, uh, if a and b are two non-zero positive numbers, and if a is greater than b, if a and b are non-zero positive numbers, they are positive and they are not zero. If a is greater than b, then this implies they are reciprocal. That is 1 by a will have the opposite relation or opposite inequality, that is 1 by a will be less than 1 by 1 by b. So we have x to the power n greater than y to the power n. So this will imply 1 by x to the power n will be less than 1 by y to the power n. So this implies what is 1 by x to the power n? That was 1 by x to the power n is nothing but x to the power m. And what is 1 by y to the power n? It is y to the power m. Hence we get this result. Now 5, 6, it says that if x is less than y, then the inequality will change. X to the power m will be greater than y to the power m. If x to the power m is greater than y to the power m, this will imply that x is less than y, where we know that m, the power, is less than 0. Now the logic is same, because so we know that if we consider m as equal to minus n, so we have now, so if x is less than y, definitely x raised to the power n will be less than y raised to the power n. So this will imply 1 by, when we take a reciprocal, the inequality changes. So hence we get x to the power m greater than y to the power m. These relations, this inequality will be used. You can apply this concept while comparing two numbers in exponential form. You will be asked to compare two numbers in exponential form, that is, which is larger or which is smaller. Okay, so these are all the concepts that I want to discuss about the rational numbers, the integral exponents of rational numbers, and the laws of exponents. So you can, if you wish, you can take a screenshot, but remember that for the point number 1, comparing exponents of rational numbers, point number 1, it will not be double implication, it will only be implication. And here we have the laws of exponents of rational numbers, and these are the basics of the exponents of a rational number. Okay, now let me try to solve few examples to illustrate the concepts. Okay. Now let's try to example problems. Example problems. Now, how do we, let's say, express, how do we express 1 by 343, that is expressing a given rational number in exponential form, expressed in exponential form. So that is, you are given expressed in exponential form. The concept is that if you are given a rational number and you have to express in exponential form, you have to convert both the numerator and the denominator in some exponential form where the powers will be same. So you have, let's say you have any rational number, given rational number p by q. You have to somehow convert these. If you are asked to express this as exponential form, it will obviously be the case that you will be able to convert the p and q, p as let's say some number raised to the power m, and q also some number raised to the power same power m. You have to do this, then this will be a by, then you can say the exponential form, the p by q will be a by b raised to the power m. Okay, now so we have 1 by 343. Now 343, now 1, we can always express 1 as in the exponential form where the base will be 1 and the powers could be any integer. I mean 1, in the numerator we have 1, we have to express 1 as in the exponential form. Now 1 can be written as 1, 1 can be written as 1 0, it can be written as 1 1, it can be written as 1 2, like this. You can have any power. But 343, you have to see 343 is there any number whose power is 343, that is square or cube or any integer n? We have to find basically find not find, we have to express 343 as integral power of some integer. Now how can we do this? Is it dividing? Now the one way is that you can do a prime factorization of the number, then you will get all the factors. From there you can express the number 343 as powers of some numbers. So 343 doesn't divide with 3, 5 6 no 7 7 7 divide with 7, 4 9. Okay, so we have this. So we can clearly see that 343 is equal to 7 into 7 into 7, this is equal to 7 cube, and 1 we can write it as 1 cube. Hence this implies 1 by 343 is equal to 1 cube divided by 7 cube. This is equal to 1 by 7 whole cube. So we have, so in the exponential form we can have 1 by 7 to the raised to the power 3. Now you can also simplify this. You can express 1 by 7 raised to the power 3 in some other form, like 1 by 7 is the reciprocal of 7. 1 by 7 is the reciprocal of 7, that is 7 raised to the power minus 1 whole raised to the power 3. You can express like this. This is also again equal to, so we have 7 raised to the power minus 1 and whole raised to the power 3. So it will be, so applying the laws of exponents, we will multiply the powers, that is minus 1 into 3 that is 7 raised to the power minus 3. So you can express 1 by 343 as this or this or this. Okay. What else? Now, a question can be asked is, you will be given a rational number. Let's say you are given a rational number 6 by 81 by 625. Now you will be asked, what is the base? The base of this number. What is the base of this number? When you are asked this kind of question, that is, what is the base of a rational number p by q? Then what you have to do is you have to express the rational number p by q in some exponential form, and in that exponential form, whatever the base is, that will be the base. So I have to first, so the question is, what is the base of this rational number 81 by 625? So I have to first convert this to exponential form. Now I know that 81 is equal to 9 square. Also 625 is equal to 25 square. Now if you say that, so 81 by 625 is 9 square by 25 square. So this is equal to 9 by 25 whole raised to the power square. Now if you say the base is 9 by 25, it will be an incorrect question, because you can still further express 9 by 25 in an exponential form. So when you are asked this kind of question, when you are asked to express a given rational number in exponential form like this, you have to express the numerator and the denominator to have the same power, to have the same maximum possible power. That is, if I am expressing p by q as equal to a to the power m divided by b to the power m, where I have expressed p as a to the power m for some number a and an integer m, and expressed q as b to the power m, then this m has to be maximum, the maximum possible. So this I know I can further convert this as, so this is 3 square, 9 is 3 square divided by 25 is 5 square, and we have whole square. So 3 square by 5 square, I can say it is 3 by 5 whole square, and this was again raised to square. So this is 3 by 5 whole to the raised to the power 4. So the number 81 by 625 in the exponential form will be 3 by 5 raised to the power 4, and hence the base of the number 81 by 625 is 3 by 5. Okay. Now simplifying these kind of expressions, let's say it is given A, B and C are some non-zero numbers. It could be non-zero integers or rational numbers. So if we have something like a raised to the power minus 2, b multiplied by b raised to the power minus 3, and c raised to the power minus 5 whole divided by a cube, a raised to the power 3, b raised to the power minus 2, and c raised to the power 4. What will be the simplified value? You will be asked to simplify this. It will be in terms of a, b and c. Okay. So for solving this kind of problems, what you do is you try to simplify, merge the common terms, that is a, b and c. In the numerator, I can see in the numerator I have. So what you can do is uh, you will uh, you will combine the similar terms, the similar numbers, uh, the similar numbers from the numerator and the denominator. That is, I will write it as a raised to the power minus 2 by, I have a cube in the denominator. This multiplied by, I will combine the b terms, I mean the exponential terms having the b as base. So this will be b raised to the power minus 3 divided by minus 2, and then I will combine the c raised to the power minus 5 divided by c raised to the power 4. So now this will be, we know that x raised to the power m divided by x raised to the power n is equal to x raised to the power m minus n. So using these laws of exponents, I can say it will be a minus 2 minus 3 multiplied by b minus 3 minus of minus 2 multiplied by c minus 5 minus 4. So this is equal to a minus 5 multiplied by b minus 3 plus 2, that is minus 1, multiplied by c minus 9. C minus 9. So this is equal to 1 by a raised to the power 5, b and c raised to the power 9. Okay, so this kind of problem you might need to solve, and another problem could be, it is all about based on the laws of exponents, and the laws of exponents, using the laws of exponents and the very primitive results, that is any rational number, non-zero rational number raised to the power 0 is 1, and the multiplicative inverse, any rational number, if its power is negative, that is a by b raised to the power minus m is equal to b by a raised to the power m. All these results and concepts and formulas, if you remember them, they are not too difficult to remember. If you practice a lot of problems, then you will get hold of all these laws of exponents and the results. Now let's try another example. So what will be the result of a square raised to the power 5 multiplied by a raised to the power 0 multiplied by b raised to the power 3, this whole raised to the power minus 2 multiplied by b raised to the power 0. Now any non-zero rational number, even though it is not given what is a and b, always assume that in exponents the base is always non-zero. So this is equal to a square raised to the power 5. So the powers will get, we will in the power, we will be in the result, the power will be the product of the powers. So a raised to the power 2 into 2 to 5. Now a raised to the power 0, that is any rational number raised to the power 0 is always 1. What is this? B cube raised to the power minus 2. So it will be 3 multiplied by minus 2, and also b raised to the power 0 is 1. So we have this. So now this is equal to a raised to the power 10 multiplied by b raised to the power minus 6. This is equal to a raised to the power 10 divided by b raised to the power 6. Because b minus 6 is equal to 1 by b raised to the power 6. Using the formula, we have that this one. A by b, if you have a rational number a by b raised to the power minus m, where m is a positive integers, minus m, then this will be, it will be equal to the reciprocal of the rational number raised to the power m. So b raised to the power minus 6 will be equal to the reciprocal of b, that is 1 by b raised to the power 6. So these kinds of, there are various kinds of problems that can be asked. When I will solve in the next video, I will solve the exercise 2a, and then the next topic will be expressing large numbers and very large numbers and very small numbers in the exponential form, or in the standard form. It is known as in standard form. I will discuss that, and then while I will solve let me see if this chapter has any. Then when we will solve the objective questions, that is exercise 2c, a lot of things will be cleared. So there are lots of variations of problem that can be asked on the exponents, and it's a very important chapter. Your concept on exponents should be very clear. This will be rigorously used in higher classes, especially in 11 and 12. There is also a test paper 2. So even though I did not do a lot of explanation with examples, please do not worry. When I will solve the problems of exercise 2a and then the objective questions, MCQ, and the test paper 2, everything will be clear. So please stay tuned for the next video, where I will solve the exercise 2a from the test book, and then I will start the next topic, which is standard form, expressing very large and very small numbers in the standard form, and then we will solve the MCQ and the test paper 2. I hope this video was beneficial. If it is so, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So thanks for watching, and until the next video, take care and bye.